today's lesson, a small like an intro for the newcomers. Since it's your first day today, I hope Miss Divya from the office communicated to you that your first class is for free, where you how to make to gane? Where I know it happens. Sorry, I was just joking. So, anyways, she must have communicated to you that the first class is for free, where you can join and you can see if the class is suitable for you, if the teacher is suitable, if everything is okay. And if you wish to continue, you can let her know, where she will arrange like admitting you as a student and her LMS access deneva, ඊට පස්සේ previous recordings owner request කරන්න පුළුවන්, all those stuff. So yes, and also since it's your first day, stay for the entire class today. And one message when it comes to communication, generally mama mandatory kala naha camera on karane ka, or even unmuting and talking maka mandatory kala naha. However, you have a few ways where you can communicate. Mama uganan athara, if you have a message, you can use raise the hand option. And then I will give you the chance to speak. And එතකොට කැමතිනම් unmute කරලා කතා කරන්න පුළුවන්. උගන්නන්න නැති වෙලේ නම් you can straight away unmute and ask any question. Unmute කරලා කතා කරන්න uncomfortable නම්, because I know some of you guys are like that, what you can do is you can use the chat box option, right? So chat box option එකේ උගන්නට to everyone දාලා main chat එකේ දාන්නත් පුළුවන්, or you can just send me a personal message. That, and also a lot of times I ask whether you understood, මේක හරිද, ලිව්වද, තේරුණාද, ඒ වගේම හැම එකකටම yes ගන්න ඕන නැහැ. You can just use the thumbs up option, right? So those are the few messages that I have to tell you guys in terms of communication during the class. And that's about it. I think අපි resultant force ඉවර කරේ. මට දැනගන්න පුළුවන්ද ඔයගලන්ට, did you all receive last week's whiteboard note ළමයි? මොකද මට හිතන්නේ මම මිස් දිව්‍යාට යවුවේ නැහැ whiteboard note එක. එහෙම මතකයක් මට තියෙනවා. I'm just asking. නෑ නේද? ඊට කලින් week එකේ ආවද? Because the last few weeks have been a little crazy, so I may not have shared the whiteboard. I shall share it with Miss Divya. මම එතකොට යා හෙට උදේ group එකට ඔක්කොම whiteboard notes pending ඒවා ටික දායි. Right? So මම මේ last week whiteboard note එක open කරගන්න හදන්නේ to see where we exactly stopped. We finished the Mohs lesson නේද? And then we were talking about resultant of two collinear forces in the same direction, in the opposite direction, and two parallel forces. All right, great. We have a very tiny bit of resultant force, and then we'll be done with that lesson. Okay. Can you put a subtopic? Resultant of resultant of two resultant of two inclined forces. So how was your last week, Lamai? Did you all have a great week? Anything interesting from your previous week, or has it been just another week? මොනවාද තොරතුරු ඔයගොල්ලන්ගේ? For me personally, it was just another week. Maria, can you tell me the date, please? මම date එක දාලා තියෙන chat box එකේ. මොකද අනිත් අයගේ? Anything interesting that happened this week? Nothing. Same here, actually. Nothing much. Then then for all of us seems like it's been quite an unhappening and a boring week. Did y'all have school the entire week, Lamai? Did y'all go to school? And can I know which lesson y'all are doing at school? Which lesson are y'all doing at school now? Okay, some of you finished part 1 book, some of you are in the sales lesson. You skip the bio parts. 13. Okay. Anita kohomada, because I know you guys are going to different schools, so I'm really interested to hear. Result and force. Okay. Then others will be starting in next week. Anita? What about others? Just let me know, Lamai. Sometimes it's good to know how schools are also proceeding. We can get an idea about our position and we can get an understanding whether we should hurry up or whether we can take it a little slow. Taking it a little slow is not really an option. Let's just do it fast. So I know you did not receive lesson 6 and 8 PDFs yet. But don't worry about it. We are going to now today finish resultant force next. Resultant force ivara karapu hatiyema ape equilibrium lesson eකට. I know the lessons are a little jumbled, but trust me, this is the sequence that works. Look at the resultant force of equilibrium we can ekavage flow in a deka. Right? So our flow is resultant force, which we are going to finish in another like 10 minutes, 5 to 10 minutes. And then equilibrium lesson. Again, as I said, it's quite a short lesson. ඒකට පස්සේ අපි යනවා rotating effect වලට. ඕක තමයි අපේ flow එක. Rotating effect එකෙන් පස්සේ අපි biology lessons දෙක කරා, chemical bonds කරා, and then we are going to the මොකක්ද අපේ 13th lesson, what is it? Classification lesson, the world of life. Right, so that's a sequence just to give you an idea. Other අපේ plan එක class එක start කරද්දී මම කියන්න, today's plan is, as I said, in the next 5 to 10 minutes we finish the resultant force lesson, and then if the plan goes well, අපි 7:30 වගේ with the resultant force ඉවර කරලා 8:30 8:45 වගේ විදිහ අපිට equilibrium ඉවර කරන්න පුළුවන්. Let's say 8:30. And then from that point onwards, we are going to do moment. As I said, equilibrium is also a short lesson. ඊට පස්සේ තමයි අපි rotating effect නැත්නම් turning effect කියන lesson එකට යන්නේ. ඒක නම් අපිට අදිවර කරන්න බෑ, obviously. There's a little bit more there. But next week we can finish that as well. So next week we'll be starting the biology lessons, right? So ඔයගලන්ට හැමලේම මම plan එක කියන්නේ so that you guys are aware. නැත්නම් නිකන් ඔහේ blindly class එකට එනවට වඩා, if you also know this is the plan that we are going to do and how we are going to do, it's good, right? So එතකොට ඔයගලන්ගේ ඔළුවේ idea එකක් තියෙනවා කොහොමද අපි ඉවර කරන්න කියලා, right? So next week we'll be finishing a turning effect as I told you before, and we'll be starting the 6th and 8th lessons, right? එතකොට අපි ඒක ඊට පස්සේ 30th June වල අපි biology lessons ඉවර කරලා 7 and 7th අපි පටන් ගන්නවා chemical bonds. Now I'm not worried about the 13th lesson because it's biology. Of course there's a little bit more. හැබැයි ඊට වඩා අපි පොඩ attention දෙන්න ඕනේ chemical bonds කියන lesson එකට. Okay? All right. So what was I saying? Yes. Did you all put the topic, Lamai? Resultant of two inclined forces? Hard. Okay. So unlike collinear forces, inclined forces වල මෙහෙමයි වෙන්නේ. Let's say we have an object like this. I will mute. One second. Okay. All right. So this is an object, right? Like it could be any object. Moka khare table ekak wenna puluwan, natham moka khare box ekak wenna puluwan. Some maybe like a big rock or a stone moka khare wenna puluwan. Right? So I'm going to apply, let's say, mama, right? I'm going to apply a force like this. Okay. This is me. I'm applying a force like this. Don't worry about the values. Lamai collinear forces in the same direction and in the opposite directions, and also in parallel forces. We worried a lot about the values because we need the values to do calculations. Fortunately, inclined forces will අපිට calculations now. Okay? In inclined forces, we don't have calculation. So we just have to get an idea only. ඔන්න මම මෙයාට force එකක් දානවා මම මේකට label කරනවා P කියලා. Then let's say චාලුක්‍යයා මේකට force එකක් දානවා මේ පැත්තට. Let's say the value of the force is Q. Right? මොකද Q කියලා force එකක්. So to which direction will the object move? To which direction will the object move? Sorry, Alia? Alia says between P and Q. Others? What do y'all think? Okay, Maria says same answer. Okay. Others? Senudi also says the same answer. Yes. So make it, there are 2 points that we need to know. First point is, when there's an object and when the object is given two inclined forces, inclined කියන්නේ collinear not parallel not just two random directions, right? So when the object is given with two inclined forces, the object will not move in the direction of P. The object will also not move in the direction of Q. But the object will move in the direction between P and Q. P and Q මැදින් කොහෙන් හරි තමයි මෙයා යන්නේ. So in a resultant එක තියෙන්නේ මේ මැද direction එකට. That's the first point. Is that clear to all of you? Give me a thumbs up, please, if that is clear. Others? All right. The second main point that we need to know is, now resultant එක යන්නේ P and Q මැදින්. But where exactly? මෙහෙම. හිතන්න P වල value එක වැඩි කියලා. So let's say for an example, P is 50 newtons. But Q, let's say 30 newtons. එතකොට ළමයි resultant will be going between P and Q, but it will be more closer towards P. So හැම වෙලෙම first point එක තමයි, when there are two inclined forces, the resultant force is between the two forces. Second point is, the resultant will be between the two forces, but it will be closer to the force with the higher magnitude. වැඩි එක්කෙනාගේ පැත්තට චුට්ටක් වැඩි වෙනවා. දැන් මෙහෙම මෙතන නම් මේ resultant force එක ඇත්තට මෙන්න මේ විදිහට ඉන්නේ. චුට්ටක් P ගේ පැත්තට ලං වෙලා ඉන්නේ. Like this. So it will be closer towards the direction of P. That's a second important point that we need to know. First point, when we have two inclined forces, resultant force is between the two inclined forces. Second point, the resultant force will be closer towards the force with the higher magnitude. Is that clear? That also is it clear? Okay. දැන් ඉතින් අපිට තියෙන්නේ එහෙනම් draw කරගන්න. Can you all start drawing with me? මේ values දාන්න එපා. P and Q විතරක් දාන්න. Can you all start drawing with me? I forgot to put the topic here. So I'll turn talk to inclined forces. The result. මගෙත් එක්කම draw කරලා මේක ලියා ගන්න ළමයා. Make it fast. Quickly write this. 3 minutes. Huh? Now the Q is there. Method resultant force will be in between the two forces P and Q. Summat board එකේ භාගයක් පේනවද දන්නේ? Can you see now? Excuse me.
No, there's no Q in that.
Why is that? 1 second, lamai. Excuse me. How about now? Can you all see the board properly now? How is that possible? How about now? Okay, give me a second, Mamika. I'm at reshare කරන්න දලුතේ. Give me a second. Mama, can you please check now? Now okay the කියලා Okay, Maria. Others? Okay, quickly write. Okay. I hope everybody's done. Exercise miscellaneous exercise there are a few questions. They're quite easy, but I will give it to you as homework. Let's quickly move on to the lesson equilibrium. Can you put now this is lesson number 12, lesson number 12, equilibrium of forces. Order again වැඩි හිතන්න එපා, because this is the order that works, right? So trust the process and just let's do accordingly. Equilibrium of forces. This is lesson 20. All right. Now, Lamai, what do you think is the meaning of the word equilibrium? Equilibrium in your own words. What is the meaning of the term equilibrium? Yes. Sorry, it's lesson 12. Ne? I'm sorry. Thank you for pointing that. Lesson 12. Chalukya, you were not there last week when I said Mafi Students of the Month announced Karpele. You got, now I can't remember what it is, but out of the 3, you were also one. And we picked 2 others. So just wanted to let you know in case you didn't hear. මං හිතන්නේ group එකේ දැම්මේ නෑ නේද? නම් list එක දැම්මේ නෑ නේ group එකේ. මම චුට්ටක් check කරන්නම්. Did you hear me now? Okay. So good job. Maintain the good work. Others also, as I said last week, you guys have been really good and very active, which I really like, right? මේ කාලේ හොම active වෙන එක හොඳයි. එතකොට අපිට you know, so you have to maintain this level of enthusiasm and passion and being active and all that. නැත්නම් ඔක ටිකක් කල් යනකොට die down වෙනවා and then you become all lethargic and lazy. So that we cannot tolerate, right? So maintain the good work and let's move forward, all of you. Okay. Right. So as I told you, as I asked you, what is the general meaning of the word equilibrium? මොකක්ද සමන equilibrium කියලා අපි කියන්නේ?
Equal force.
Equal. Equal what? So something's equal or like something's balanced. Some equilibrium can is something like a balance, right? So in this lesson, so balance is just a normal word. Scientifically, we are using the word equilibrium. So we are talking about how things are maintained in equilibrium or how things are balanced, right? So एक आप एक forces वली कथा करना. Okay. So for an example, let's say there's an object. මෙහෙම තියෙනවා table එකක් උඩ. And this is a table. So this object is just there resting on the table. Is this object in equilibrium?
Yes.
Okay, others, what do y'all think? Is it in equilibrium? If it's not moving, it's in equilibrium. Yeah, balance again. Right? That's why it's all moving. If there was no equilibrium, this would have been moving. හැබැයි මෙයා move වෙන්නේ නැහැ. මොකද මෙයා equilibrium ඉන්නේ. What are the forces acting on this particular object? What are the forces acting on this particular object? What are the forces acting on this object?
Gravitation.
Yes, gravitational force. Yes, that means weight, right? Yes. Yes, Maria, correct. And Alia, correct. Weight. Weight හැම වෙලෙම මෙහෙම පල්ලෙහාට තියෙන force එකක්. So weight downwards. So if it was just this force, this object would have gone down. හැබැයි does this object have another force? මෙයා තම හරි force එකක් තියෙනවද?
Yes.
What is it?
Like perpendicular.
Correct. Yes, Alia, and I got another answer. Where was the other answer? Perpendicular. Yes, yes, Chalukya. Perpendicular reaction force. When there are two surfaces in contact, there is a force that each surface gives to the other. එතකොට මේ table එකෙන් මේ box එකට upward force එකක් දෙනවා, that is the perpendicular reaction force. So if this particular object is in equilibrium, මොකද වෙන්නේ? Equilibrium කියලා කියන්නේ all the forces should be equal or they should be balanced. So here resultant force perpendicular reaction force is equal to the weight. That is why we say this is balanced. Balance කියලා කියන්නේ it's in equilibrium, therefore it is not moving. Is that clear to you? Is that clear to all of you? Give me a thumbs up, ළමයි. Okay, let's take another instance. මෙහෙම තියෙනවා මොකක් හරි ceiling එකක් හරි මොකක් හරි, right? So an object is hanging like this. From the ceiling, an object is hanging. What are the forces acting on this object?
Weight.
Yes, weight downwards. Anything else? Anything else? මට කලින් වෙන answer එකක් ආවා. කලින් එකට වැරදි, but it could be correct to this.
Tension.
Yes, Alia, and yes, Chalukya, it's tension. When anything is hanging, there's a force tension. So object එක මෙහෙම hang වෙද්දි මේ පැත්තට තමයි tension තියෙන්නේ. Again here, tension is equal to weight. That is why this object is not moving and it's stationary. We call it equilibrium. Okay, so here perpendicular reaction force and weight are equal, so it's in equilibrium. Here tension and weight are equal, so it's in equilibrium. So let's consider another instance, right? Another instance where we have an object like this on a table again. අපි බලමු horizontally කොහොමද වෙන්නේ කියලා. So let's say A කියලා student ගෙනේ මෙයාට දෙනවා force එකක් 22 newtons. And then B කියලා student ගෙනෙන් මේ පැත්තෙන් දෙනවා මෙයාට force එකක් 22 newtons. Shweta, R means perpendicular reaction force. Remember when we were learning friction, we talked about it. When two surfaces are in contact, they give each other a perpendicular force. That's perpendicular reaction force. R can, yeah. All right. So now is this object in equilibrium? Is this object in equilibrium? Alamin? Yes. why A is pulling it with 22 newtons, but B is also pulling it with 22 newtons. So, they pattara balance වෙනවා. Therefore, A is equal to B. එහෙනම් මේ ඔක්කොම instances මොනවාද? These are examples for equilibrium. Can you all quickly sketch these diagrams, and then what I write, you can write at the bottom quickly. So, textbook එකේ තව එක example එකක් තියෙනවා. I thought of talking about it. Tug of war, right? ඒ කියන්නේ කඹ අදිනකොට අවුරුදු කාලෙට හරි just as a game හරි කඹ අදිනකොට, let's say both the teams pull the rope with the same force. Will the rope move in any direction if both the teams are pulling it with the same force? No, because then it will be, yes, then it will be in equilibrium. However, එක team එකක් වැඩි force එකක් දුන්නොත්, now it will not be in equilibrium, so the rope will be pulled towards that direction, right? So ඒ වගේ තමයි හැම වෙලේම, always if there is an equilibrium, that means the opposite forces are equal, right? So you have to remember that. Okay, quickly start sketching the diagrams, and I'll write a point down here. Make a label කරගන්න Roman number 1 කියලා. This is Roman number 2. This is Roman number 3. Please make it fast, lamai. One second. Right. Okay, just this part. Make it fast. ළමයි බලන්න මේ last. So okay, if you look at this particular instance, the third Roman number, A is 22 newtons, B is also 22 newtons. Can I ask you what is the resultant force in this second instance?
0.
Okay, Alia says 0. If you look at this third instance, what is the resultant force? Yes, it's 0. හැම වෙලේම equilibrium ඉන්නවා නම් there can't be a resultant force. So always when any object is in equilibrium, that means the resultant force is 0. So it's an important point. Let's write that as well. මාත් එක්කම ලියා ගන්න. When the resultant force is equal to 0, the object is in equilibrium. Very, very important. All right. Now let's talk about a few instances. මුලින්ම අපි කතා කරනවා how an object is in equilibrium under two forces. Then we are going to talk about how an object is in equilibrium under three forces. So එතන අපි කතා කරනවා parallel and non-parallel කියලා දෙකක්, right? And then we are going to be talking about how an object is in equilibrium under more than three forces, right? So this is the lineup. Equilibrium lesson එකේ මම resultant force වලත් ඔයගලන්ට අර categorize කරලා පෙන්නනවා. This is what we are going to discuss in the lesson කියලා. So like that, in equilibrium of forces, this is what we are going to talk about. මුලින්ම අපි කතා කරනවා equilibrium of an object under two forces. Forces දෙකක් එක්ක කොහොමද equilibrium ඉන්නේ. Then we are going to talk about how an object is in equilibrium under three forces, when there are three forces. And in the next one, we are going to discuss how an object is in equilibrium under more than three forces. Any forces තුනකට වැඩි. So this is the basic lineup. Under this three force one, we are going to be talking about two types. එකක් තමයි three parallel forces. The other one is three non-parallel forces. So this is the lineup of today's lesson. Is this clear to all of you? ළමයි? මේක clear ද ඔයගොල්ලෝ හැමෝටම? This is what we are going to be discussing in this lesson. And we are going to discuss everything today. Okay, quickly sketch the basic outline of the lesson. Make it aggal liya ganna, make it fast. Okay, now for the subtopic, equilibrium of an object under two forces. This is our first subtopic. දැන් අපි කතා කරන්නේ මෙන්න මෙයා. We're talking about this. Quickly put the subtopic. Now this is quite simple, right? දැන් අපි කතා කරපු විදියටම තමයි. Now look at these examples. If you look at this is what we discussed earlier, ළමයි. Yeah. If you look at this example, can you see how many forces are here? How many forces can you see here? Two, right? And is the object in equilibrium? Is the object in equilibrium? Yes. The object is in equilibrium and there are two forces. එහෙනම් මෙයා අපි දැන් කතා කරන එකට included. Let's look at example 2. How many forces are there? How many forces? Two. Yes. Equilibrium or not?
Equal.
Equilibrium. So this is included in what we are going to talk about now. Here also the same two forces equilibrium. So that is also the same case. And now when we are talking about equilibrium of an object under two forces, all those previous examples we can talk about. Okay. So mama just examples dekak vitarak draw karanna. So this is the table, this is the object. As we said, when there is weight like this and there's perpendicular reaction force like this. So as we said, perpendicular reaction equals weight. Then if we, in the other example, we talked about how like when an object is hung like this, there's weight downwards, tension upwards, and we said tension is equal to weight. අරකට නිකම් බැලුවොත් දැන් අපි හිතමු I give a force to this direction 10 newtons. ඒක මම පස්සේ කියා දෙන්නම්. So these two examples are the same as what we talked about earlier, right? Now if you look at something like this. Now, let's say Shanaz is giving this object a force 15 newtons to this direction. And let's say Thisuri is giving this object another force in the opposite direction, 15 newtons. Is the object in equilibrium? Huh? Yes. How many forces are there? Two. Ehang, this object is in equilibrium. Now, this is what I want to do. I want to maintain the equilibrium of the object. මේ object එක equilibrium එක මට maintain කරන්න ඕනේ. So, මම කියනවා Shanasta make a force එක increase this to 22 newtons කියලා. Then, if I want to maintain the equilibrium, what should Thisuri do here? What should Thisuri do here?
Increase the amount of force.
Sorry, Alia?
Increase the force.
Increase the force. Yes. And Tisurit make increase karanna ඕනේ 22 newtons වෙනකම්. Otherwise, this won't be in equilibrium. So, always the magnitudes have to be equal. Okay? So, when two objects are examples, but we are learning something new here. When an object is in equilibrium under two forces, ඒක satisfy කරන්න ඕනේ, there are three conditions. Don't write anything, Lamai. I will give time, so just listen. Let's see what are the conditions that need to be satisfied. ලියන්න එපා. මම change කරන note එක. First එක තමයි the two forces must have equal magnitudes. Okay. So if you look at these three instances, as previously mummy have Roman number 1, Roman number 2, and Roman number 3 kila label karo. Do in all three instances, do the two forces have equal magnitudes, Lamai? Do they have equal magnitudes? If you look at all the three instances, what do you think?
Yeah.
Others, what do you think? Do you all agree? No? Which one doesn't have equal magnitudes? Yes. As I said previously, perpendicular reaction force and weight are equal. Tension and weight are equal. 22 Newton equal. So the two forces must have equal magnitudes. That is correct. A condition like satisfy when the mode. For an object to be in equilibrium under two forces, the first condition that needs to be satisfied is this. The second condition is the two forces must act along opposite directions. Look at our examples. In every example, are the two forces in opposite directions? Yes. Here, perpendicular reaction force up, weight down, opposite directions. Correct. Here, tension up, weight down, opposite direction. So that is also correct. Here, 22 newtons to left. Here, 22 newtons to right, opposite directions. That is also correct. So that is the second condition that must be satisfied. Then what is the third condition that needs to be satisfied? Both forces, both forces must have the same line of action. एक याने lamai, एक याने, if you look at the two forces, they should have the same line of action. एक याने our forces will lines like join kar हम यहाँ गांठ एक विधि रहने. Now if you look at this one, see, मेयागे line of action like मेका, मेयागे line of action like मेका. See, they have the same line of action. Correct. So if you take tension, this is the line of action. If you take weight, this is the line of action. See, they have the same line of action. If you take this 22 newtons, this is the line of action. If you take this 22 newtons, that is a line of action. They also have the same line of action. If all these three conditions are satisfied only, an object will be in equilibrium under two forces. Then equal වෙන්න then opposite වෙන්න then එකම line of action තියෙන්න ඕනේ. Is that clear to everybody? Give me a thumbs up, please. Others? Yes, Kushit, what's the question?
Nothing.
Right, all good, no? Okay. Okay, can you all quickly write this down, Lamin? Quickly write it down. If you have questions, let me know in the chat box, huh? I'll give you like 1 more minute. All right, Lamai. Now that is equilibrium of an object under two forces. So na pihenang eka complete kara. We finished that. Right. So na this is done. Now we are going to be discussing equilibrium of an object under three forces. First we are going to be talking about three parallel forces. All right. So put the topic. Equilibrium of an object under three parallel forces. Under three parallel forces. Three coplanar parallel forces. All right. So first of all, I'm going to talk about what the conditions are. Mulima conditions tika kya dena. Right. So, Mataka Malayana conditions tika, and then let's talk about examples later on. Conditions that need to be satisfied. Excuse me. Number one, the three forces must be coplanar. I will explain all of this. Huh? Number two, one force must have a direction opposite to the other two forces. That's number two. Number three, the resultant of any two forces must be equal in magnitude and opposite in direction. So these are the three conditions. Quickly write the three conditions and then I will explain all of these three with like a few examples. Make it fast. Okay. Now let's talk about, did you all write, everybody? Give me a thumbs up if you finished writing. Did all of you finish writing? Okay. So let's talk about a few examples. The first example that I'm going to talk about is මෙහෙම එකක් hang වෙනවා. So let's say there's no, let's take something like this. So මෙහෙම තියනවා පොඩි what do you call it, like a bench. මේ තියෙන bench එකේ කකුල් දෙක, right? And then this is the ground, the floor or the ground or whatever. So this bench is just lying on the floor or the ground. Is it in equilibrium? What do you think? Is it in equilibrium? Okay, I'm getting yes and no answers both. Okay, tell me, what are the forces acting on this object? What are the forces acting on this object?
Weight.
Weight. Always from the very center of the object, we get weight, which is being applied downwards. Anything else?
Perpendicular reaction.
Perpendicular reaction. Balanna, the bench is in contact with the ground at two different locations. Methanath, the bench is in contact with the ground. Here also the bench is in contact with the ground. Then we are getting two perpendicular reaction forces. Wherever two surfaces are in contact, each surface gives the other a perpendicular reaction force. එහෙනම් මෙතන එක perpendicular reaction force එකක් තියෙනවා. And here there's another perpendicular reaction force. Since we have two perpendicular reaction forces, this one I shall label as R1 and this one I shall label as R2. Is the situation clear first of all? Situation එක තේරුණාද හැමෝටම before we talk about everything else? Right. Hari, then let's look at the conditions. The three forces must be coplanar. Coplanar කියන ළමයි, the forces have to be on the same plane. Same plane කියලා කියන්නේ අපිට මෙහෙම draw කරන්න පුළුවන් වෙන්න ඕනේ. Now for an example, let's say we have an object like this. So this is my phone, right? Then make it a මෙහෙම පල්ලෙහාට force එකක් තියෙනවා. තව මෙහෙම පල්ලෙහාට force එකක් තියෙනවා. තව මෙහෙම ඉස්සරහට force එකක් තියෙනවා. පල්ලෙහාට forces දෙකයි. I don't know if you can see. මෙතන පල්ලෙහාට force එකයි, මෙතන පල්ලෙහාට force එකයි, and then ඉස්සරහට force එකයි. Is it coplanar? Is it coplanar? Can we draw this on a piece of paper? පල්ලෙහාට තියෙන forces දෙක නම් මට draw කරන්න පුළුවන්. මෙහෙම ඉස්සරහට තියෙන force එක මට draw කරන්න පුළුවන්ද? කොලයක? No. Can't. කොලයක draw කරන්න බැරි දේවල් තියෙනවා නම් ඒ single plane නෙවෙයි. Then we call it 3D. But 3D වලට මේව වැඩ කරන්නේ නැහැ. Right? If you want to make an object in equilibrium under three parallel forces, the three forces must be coplanar. එකම plane එකක තියෙනවා. That's the first requirement that is satisfied. Second one force must have a direction opposite to the other two forces. ඒකත් හරි බලන්න මේ. That means එක force එකක direction එක අනිත් දෙන්නට opposite වෙන්න ඕනේ. R1 and R2 have the same direction. Other two forces, they have the same direction. Weight is in the opposite direction. So one force must have a direction opposite to the other two forces. That condition is also satisfied. All good. Then next one is the resultant of any two forces must be equal in magnitude and opposite in direction to the third force. ඒ කියන්නේ ළමයි R1 and R2 ගත්තොත් එහෙම these are two different forces no. මෙයාගේ resultant එක R1 ගේ R2 ගේ resultant එක කියලා කියන්නේ what is the one force that I can use to replace R1 and R2 with the same effect. R1 R2 වෙනුවට ඒ effect එක මෙන්න මට දාන්න පුළුවන් කවුද? Let's say R1 ගේ R2 ගේ resultant එක මෙහෙම කියලා. Let's say this is the resultant. Then the third force, which is W, is equal to that resultant. So R1 ගේ R2 ගේ resultant එක කියන්නේ R1 ගේ R2 ගේ resultant means R1 plus R2, right? And according to this, the resultant of any two forces must be equal in magnitude and opposite in direction to the third force. ඒ කියන්නේ R1 and R2 ගේ resultant, which is R1 plus R2, should be equal to W. Therefore, W equals R1 and R2, but the directions are opposite. Direction is opposite. Opposite direction, equal magnitude. Is that clear to all of you, Laman? Is this clear to all of you? Give me a thumbs up. All right. Three forces are coplanar. One force has a direction opposite to the other two forces. Resultant of the two forces is equal in magnitude and opposite in direction to the third force. All right. Quickly copy this. අපි තව එක example එක discuss කරලාමු. Okay. So Roman number 2. Don't write. Just listen. හිතන්න ඔන්න තියෙනවා පොඩි bar එකක්. Bar එකක් කියන්නේ just like a beam or something like that. Beam එකක්. අපි හිතමු have you all seen like old තරාදිය? ඉස්සර කඩවල තියෙන scale එක දැක්කද? තරාදිය පරණ තරාදිය. Yeah? I hope all of you have seen. Okay, great. Make a තරාදියක්. හරිද? I think that makes it easier. This is a තරාදිය. So තරාදියේ එක පැත්තක මම ඕන එකක් මොකක් හරි එල්ලලා තියෙනවා. weight එකක් හරි මොකක් හරි. අනිත් පැත්තට තව මොන හරි එල්ලලා තියෙනවා. And this තරාදිය is hanging by a thread or something like that. Okay. Now, what are the forces acting on this particular object? What are the forces acting on this particular object?
Weight.
Okay. තරාදිය weight එක අපි නැහැ කියලා හිතමු. තරාදියේ weight එකක් නැහැ. Let's just assume that. මම පැත්තෙනුත් ලියන්නම් ඒක. Let me write it here because නැත්තම් පැටලෙනවා ඔයගලන්ට. Assume that the beam doesn't have a weight. Beam එක කියන්නේ මේ කොල්ල වගේ එක. This one. This is the beam. This doesn't have a weight. Okay, just assume that. Now tell me. Now tell me, what are the forces? Okay, weight. What weight? What weight do you mean? Hmm?
Weight of the object.
Weight of the object. Now there are two objects, right? So here this object එකට වෙනම weight එකක් තියෙනවා. That's W1, let's say. This object has another weight. Let's say that is W2. And then you guys correctly said that tension. Tension මෙහෙම උඩ පැත්තට තියෙනවා. Now can we see here that we have one force weight, we have another force weight, and we have another force tension. Are the three forces parallel, Ame? Are the three forces parallel?
Yeah.
Yeah. Now let's look at the conditions. The three forces must be coplanar. එක හරි. We were able to draw it on a piece of paper, right? That means it's coplanar. One force must have a direction opposite to the other two forces. Hari. W1, W2 in one direction. Tension is in the opposite direction. So, here direction එකත් හරි. Third decker resultant of any two forces must be equal in magnitude and opposite in direction to the third force. ඒ කියන්නේ මෙතන we can see, sorry, weight 1 and weight 2 are in one direction and tension is in the opposite direction. Here, tension is equal to W1 plus W2. And directions are anyways opposite. Because W1 and W2 get resultant take a W1 plus W2. And that is equal to tension. Is this clear, Laman? Give me a thumbs up. Others? Okay, great. Quickly write the Roman number 2, Roman number 1 and Roman number 2. Make it fast. Huh? Quickly. One more minute lamai. All right, I think that is enough time. Did you all finish writing? Give me a thumbs up, please. Okay. ඒ කියන්නේ අපි මේකත් ඉවරයි. Now we are done with this also. Now we have to do this part. 3 non-parallel forces. So let's put a topic. Our note is a little colorful today, no? Okay, put a topic. Equilibrium of two. Kalau first the topic checked under 3 covalent of an object under 3 non-parallel forces. Put the topic. Okay. So just like previously, let's write the conditions. Conditions that need to be satisfied. Okay. First condition, the 3 forces must be coplane. ඒ කියන්නේ එක plane එකක forces තුනම තියෙනවා. එක plane එකක කියලා කියන්නේ you should be able to draw it on a piece of paper without a problem. Then second one, the lines of action of the 3 forces must meet at a common point. That part I will explain to you with a diagram. Excuse me. And lastly, third one is the resultant of any 2 forces should be equal in magnitude and opposite in direction to the third force. So these are the conditions that need to be satisfied. So let's look at an example straight away. ඔන්න දැන් හිතන්න ඔයගලන්ගේ ස්කූල් එකේ white board එක හරි white board එක ගොඩක් කාලේ paste කරලානේ තියෙන්නේ. කියන්නේ fix කරලානේ තියෙන්නේ. Let's take something like when you hang a calendar or like a picture on the wall. So this is what happens, right? So ඔන්න මම hang කරනවා picture එකක් wall එකේ. Okay. So මෙන්න මෙහෙම hang කරලා තියෙනවා. Like this. One second. Normal. Okay. So what are the forces acting on this object? What are the forces acting on this object?
Weight.
Weight. Yes, correct. What else? Okay, weight. What else?
Tension.
Tension. So now we can see there are two ropes, right? So there should be two tensions. එක tension එකක් මෙහෙම තියෙනවා, I'll label that as T1. There's another tension like this, I'll label that as T2. First condition is the three forces must be coplanar. ඒක හරි. Because අපිට draw කරන්න පුළුවන් කියලා කියන්නේ ආ coplanar. Right? Second one, the lines of action of the three forces must meet at a common point. බලමු අපි. If you look at the මම මේක draw කරන විදිහ ඔන්න බලන්න just to show you. අපි T1 එක ගත්තොත් එහෙම මේ තමයි යාගේ line of action එක. Let me see. මේ තමයි යාගේ line of action එක. I'm sorry, I'll be like පොඩකින් මේක පොඩක් පල්ලෙහාට move කරමුනේ. Otherwise we don't have enough space, no? Okay. So this is the line of action of T1. Oh, no. Right? Then line of action of T2. Line of action of T2 is something like this. This is the line of action of T2. All right. Then if you draw the line of action of W, which is our other force, that should be something like this. I'm going to manipulate a little because my diagram is not the best. 1 second. Okay. So you can see with purple, I have shown the line of action of T1. With green, I have shown the line of action of T2. With red, I have shown the line of action of W. Can you see that they are meeting at a common point? පේනවනේ දෙගොල්ලන්ගේ common point එක meet වෙනවා. So they're all meeting here. This is the common point. Therefore, this object is in equilibrium under three non-parallel forces. In addition to that, another condition that need to be satisfied is the resultant of any two forces should be equal in magnitude and opposite in direction to the third force. ඒක ළමයි අපි ලොකුවට මෙතන කතා කරන්නේ නැහැ මොකද අපි now if you take T1 and T2 they're inclined forces. We don't know how to find the resultant of inclined forces. We only have an idea but we don't know how to get the value. ඒකින් අපි එක ගැන කතා කරන්නේ නැහැ but just know when an object is in equilibrium under three non-parallel forces, all of the forces දෙකක ඔයා resultant එක calculate කරොත් එයා third force එකට equal in magnitude and opposite in direction. Okay. So this is about the third condition. Is this clear to all of you? Give me a thumbs up, please. Okay, quickly copy this down. I will give you like 4 to 5 minutes, 5 minutes, 3 to 4 minutes. Make it fast. Quickly. All right, lamai. I think up to that point it's clear, and with that we have ended this part also. Mekat ivarai. And we have the last part එක හරිම simple. That is equilibrium of an object under more than 3 forces. So ඒකේ අපිට මුකුත් ලොකුට ඉගෙන ගන්න දෙයක් නැහැ, just to write a few points only. Put the topic equilibrium of an object under more than 3 forces. Give me a second, lamai. Okay. So yes, I asked you to put the topic. මාත් එකම ලියා ගන්න. මාත් එකම ලියා ගන්න ළමයි. I will explain, just write. මම පස්සේ explain කරන්න once you are done writing. So මේක ඇවිල්ලා පොඩි swing එකක් හරි මොකක් හරි wood, a piece of wood, right? So it's suspended by 4 strings. මේ වගේ strings 4කින් එල්ලලා තියෙන්නේ යා. So how does it stay in equilibrium? Now, since it's suspended by 4 strings, we have 4 tensions, T1, T2, T3, and T4. The 8 tensions hatarai, and we know downward direction we have the weight. So these should be balanced. So conditions, value monatma pe syllabus ke naha. Just you need to know that situations like this also exist. ඒ වගේ වෙලාවට තියෙන ඔක්කොම forces ටික balance නම් that object is in equilibrium. That's all you need to know. Quickly write and sketch this one, lamai. Make it fast. And we are done with the lesson. quickly write lamai, and then we'll move on to turning effect. Okay. All right, Lamai. I think that is enough time. One second. Yeah. Let's put the topic turning effect of a force. So we are doing lesson number 11 now. Okay, so before we move on, can you all tell me, do you all have any questions in lesson 12? Any questions, any doubts, any places that you didn't understand? Karat, you know them. Okay. If not, give me a thumbs up. If everything is clear, give me a thumbs up. Others? Tisuri, Tenuji, Shweta, Usanda, Priyasha, Kushit, Jaden, Gashani, Chalukya. All good? Okay. So put the topic. Let's do lesson number 11. Turning effect of a force. ඔගොල්ලෝ මේ topic එක දාගන්න ළමයි topic එක දාගෙන just give me like 3 to 4 minutes. I will quickly be back. එතකොට topic එක දාගෙන wait for me. All right, ළමයි. So, now in turning effect of a force, we are going to be talking about rotations, right? So, all this time, අපි ගොඩක් කතා කරේ linear motion ගැන. ඒ කියන්නේ, in the second lesson, we had a physics lesson, and then now we talked about resultant force, equilibrium, Newton laws, friction. ඒව ඔක්කොම linear forces. But we never talked about rotational forces. So today we are going to be talking about rotations. Please give me like 1 to 2 minutes. I will switch on my camera. Until then, I will keep it off. Okay. So then සාමාන්‍යයෙන් when we are talking about a linear motion, we talk about force. Force වගේම when an object is rotating, we are using another term called moment. Right? We are using another word called moment. So moment කියන්නේ මෙන්න මෙහෙම එකක්. Now let's say we have an object like this. මෙහෙම object එකක් තියෙනවා. මේ object එක මෙතනින් fix කරලා තියෙනවා. Okay. So this object is fixed here. So around the fixed point, I'm going to rotate this object. Can මෙහෙම තියෙන object එක the rotation is not coming very nicely. But 1 second. It's fixed here now. So the object can rotate around the fixed point. මේ fixed point එක වටේට යාට rotate වෙන්න පුළුවන්. So මෙහෙම ඉන්නවා, and then in a bit it will be like this. And then it will be like this. Again, මේ පැත්ත fix වෙලා තියෙන්නේ, but I can't show it like this. If I show you in a different way, what can I use for this? Give me a second. Okay, I have the weirdest prop. It's a nail cutter, but මට දැන් ළඟ අහුවෙන එක මොකද මේ my pencil case is not with me. Sorry. So let's say this is the object, right? This object is fixed here. So around the fixed point, I can rotate the object, right? මෙතන fix. මෙතන move වෙන්නේ. But around this, I can move this object. I switched off the blur so that you could see it better. This is the object. It's fixed here. මෙතනින් fix කරලා තියෙන්නේ. Around the fixed point, I can rotate the object. Like this, I can rotate the object. Is that clear to all of you, ළමයි? Right? So when I'm rotating, then මෙහෙමනේ තිබ්බේ මුලින්ම. But I cause the rotation. To cause a rotation, I need to apply a force. Right? මම දන්නේ ඔයාලට පේනවද කියලා. So here, in order to create a rotation here, now this is fixed here, right? So in order to create a rotation, I need to apply a force. So මෙයාට මම මෙහෙම force එකක් දානවා. See? I'm applying a downward force like this. I'm applying a force, because of that, this object is rotating. So any object you can get like that. I'm surprised I did not have a better object to show this to you, but I hope it's clear, right? So, okay. So that's what I was saying. So, if I want to create a rotation here, I need to apply a force. So let's say the force that I'm applying is 10 newtons. Let's say I'm applying a force of 10 newtons. Okay. And this is the fixed point. Right, this is a fixed point. And this is the point where I apply the force. The point where I apply the force, we usually call it line of action. Action එක දෙන තැන තමයි අපි line of action කියලා කියන්නේ. මෙතනනේ fix කරලා තියෙන එක. So if you take this object, it's fixed here. And I'm rotating it like this. But the fixed point doesn't change. And the object is rotating around the fixed point. So fixed point එකට අපි කියනවා axis of rotation කියලා. Axis of rotation. The fixed point is called axis of rotation and this is called line of action. So let's say the distance between the axis of rotation and the line of action is, let's say, 2 meters. So we have an object, we have a fixed point. Fixed point එකක් තියෙනවා කියන්නේ එතන තමයි axis of rotation. And then we have the place where we apply the force, that is a line of action. And we know what the force is. We applied a 10 Newton force. And we know the distance between the axis of rotation and the line of action. එහෙනම් අපි moment කියන එක calculate කරන්න මෙහෙමයි. Moment equals force, the force that we apply, multiplied by perpendicular distance from the axis of rotation to the line of action. So here, the force is 10 newtons. The perpendicular distance from the axis of rotation can metana, line of action can metana, the perpendicular or the straight distance is 2 meters. So 2 meters. 10 multiplied by 2 is 20. Newton multiplied by meters is Newton meters. And this is the moment. Did you all understand this? අපි linear motion වලදී ගොඩක් කතා කරන්නේ force ගැන විතරයි. But when we talk about rotations, we talk about moment. Okay. So yes, moment equals force multiplied by perpendicular distance from the axis of rotation to the line of action. Here the force is 10. Distance is 2 meters. 10 times 2 is 20 Newton meters. Okay. So the unit is Newton meters. I hope you noticed that. Unit is Newton meters. Hamale moment wala unit taka Newton meters. Is that clear to all of you, Lamai? All right. Can you all quickly write this down? Quickly write it down. Quickly write. Done, ළමයි? Others? Others, have you all finished? Okay. Put a subtopic. Investigating the dependence of moment on the magnitude of the force. Investigating the dependence of moment on the magnitude of the force. Quickly put the topic. Okay. So what this means is that now if we take, so let's say මෙහෙම table එකක් තියෙනවා. Right, මෙහෙම table එකක් තියෙනවා. Table එකට fix කරලා, let's say there's a ruler or like a stick of wood. Ruler එකක් හරි මොකක් හරි මෙහෙම wood, stick of wood තියෙනවා. Let's say it's a stick of wood, right? And it's fixed here by a screw. Screw එකකින් fix කරලා තියෙනවා. Okay. I'm going to measure a distance of about අපි ගමන එකක් 30 centimeters වගේ distance එකක් measure කරලා ඔන්න මෙතනින් තමයි මම force එක apply කරන්නේ whatever the force it is, right? So initially මම මේ screw එක ගොඩක් තද කරන්නේ නැහැ. I don't tighten the screw a lot. I just keep it a little loose. ගොඩාක් loose නෙවෙයි ඒකට ගැලවෙනවනේ. Not very loose, but සාමාන්‍ය ගානේදී I keep the screw and I slowly apply a force here. මේ point එකට හිමීන් force එකක් apply කරනවා. So I keep applying the force and චුට්ට වැඩි කරනවා. වැඩි කරද්දී I can see that, let's say for an example, at 10 newtons, this ruler starts to rotate, right? So when the screw is a little loose, මම පොඩ්ඩ force එක වැඩි කරනවා, and then at 10 newtons, this object will start to rotate. Is the first instance clear, ළමයි? Is the first instance clear? Okay. Yes, I'll explain again. Now there's a table and I have a stick of wood. Like a ruler නැතුව අපි ගමු නිකන් wood piece එකක් තියෙනවා. එයා මම screw එකකින් තමයි මෙතන connect කරලා තියෙන්නේ. I have connected it here using a screw. Okay. But I don't tighten the screw a lot. මම ගොඩක් tight කරන්නේ නැහැ. I keep it a little loose. And then I measure about 30 centimeters and then I pick this point. මම මේ point එක තමයි decide කරන්නේ මෙතන තමයි මම force එක apply කරන්නේ. So I don't change the distance. I have a fixed point where I will apply the force. Now the screw is not very tight නේ. මම මෙතනදී I apply the 10 Newton, sorry, I apply a force. Initially නිකන් පොඩි force එකක් දානවා 2 newtons වගේ. So it's still the ruler is not rotating. I keep on increasing the force. 3, 4, 5, 6. Still it's not rotating. 7, 8, 9. Still it's not rotating. And when I increase it to 10, now the piece of wood will start to rotate. Is that clear? Is that clear, Lamai? Okay. Then, on initially, the force that I require is 10 newtons. Now what I do is I tighten the screw. මේ screw එක මම tight කරනවා එක පැත්තකට කරකවන්න එපා tight කරන්න. මම නිකන් half වගේ rotate කරනවා. Like I don't rotate it like a full circle. I rotate it half a circle, right? After rotating the screw half a circle, then මම බලනවා කොච්චර force එකක් ඕනේද කියලා. Then 10 newtons apply කරාට මදි. Why the screw is a little tighter? Then I keep increasing 11, 12, 13, 14, 15 වෙච්ච ගමන්ම it will start to rotate. Now 10 newtons is not enough, but if I increase the force up to 15 newtons, now the piece of wood will start to rotate. Is that clear? Okay. Now what I do is I rotate it another half a circle. I can do full circle එක. ඉස්සරහා half a circle rotate කරා. Then මම තව half a circle rotate කරනවා. That means altogether I have rotated a full circle. So after rotating the screw a full circle, then 15 newtons madi. Why? The screw is tighter. So now I increase it 16, 17, 18, 19, 20, 21, on a 22 again. These are just random numbers, Lamai, just example numbers only. At 22 newtons, this will start to rotate. Okay. Can you see that? Rotate වෙනවා කියන්නේ moment එක. Rotating means moment. Here, moment depends on the force, right? For moment කියන්නේ screw එක තද වෙන මම වැඩියෙන් force එකක් දෙන්න ඕනේ moment එකක් create කරන්න. Moment means the rotation. So when the screw is getting tighter and tighter, if I want to create a rotation, I have to keep increasing the force. But has the distance changed? Has the distance changed anywhere? No, distance has not changed. But to create a moment, I have to increase the force. Otherwise, there will not be a rotation. Okay? Is this clear to all of you, Lamai? All right. Let's start to write this. Kapata liyan, මාතකම ලියාගන්න මේ ටික. Start writing it. මුලින්ම rotate කරන්න ඕනේ force එක තමයි F1 කියලා කියන්නේ. I hope all of you can see the board. Quickly write this down, right? Okay, Lamai. Done writing or do you all need more time? Since there's a little bit more to write here, just checking. Okay, some of you are done. No, okay, no worries. I'll give you some time. මෙතන චූටි change එකක් මට කරන්න ඕනේ. Here I have not mentioned F1, F2, F3 නේ. මෙතන F1 කියලා mention කරන්න. F2 one second. Here just mention it as F without giving the value. මෙතන label කරන F which is 22 newtons. Also ළමයි just a little something ඔයගලන් පස්සේ confuse වුණොත් කියලා මම මේ පොඩි දෙයට add කරන්නම්. ඔයගන්ට චූටි point එකක් වගේ දාලා add කරන්න ඔයගලන්. These are only example values. පස්සේ ඔයගලන් හරි වෙන කෙනෙක් හරි note එක බැලුවොත් එහෙම confuse නොවෙන්න let's add that little note too. යම් පැත්තෙන් පොඩියට ලියා ගන්න. These are only example values. Okay. Quickly, I'll give you 2 more minutes. Okay, time is up. Now, 1 second. Okay. This is the last section that we'll be doing before we end the class. Can you all put the topic? But now we are going to talk about the perpendicular distance. Quickly put this topic, ළමයි. Make it up මුලින් ලියලා ඉමු and then I will explain. Wait, don't copy it yet. Let me change it a little bit. Just write with me. Don't worry about the context because I will explain it. Just write with me. Make it fast. I know it's a little bit too much to write, but please do because Hasemeka Padankarat, you need to have context of what has happened here. Textbook එකේ වගේ නැතුව මම normal අපිට understand කරන්න පුළුවන් විදිහට මේක write මේ ලිව්වේ. But once I'm explaining it using a diagram, it will be clearer. Just write for now. Quickly write. If you're done, let me know. All right. I have missed some messages in the chat box. I'm sorry. I reply to them now. Who needs more time, Lamai? Who needs more time? Okay. So, since our time is running up, we'll wrap up for today. Next week, we have to discuss this diagram, then talk about resultant and equilibrium in the moment lesson. Moment lesson එකේ තියෙන resultant equilibrium. එතන තමයි we have to do calculations and then couple of forces. And we'll be done with this lesson. මොකද මම moment එකට පස්සේ කරනවා කියලා කිව්වේ ළමයි? The biology lessons, I think for the biology lessons, I also have a plan to maybe organize a separate seminar. But ඒකට අපිට holiday dates තියෙන්න ඕනේ. දැන් මේ දවස්වල පොසොන් පොය දවසේ නම් morning I have a grade 11 extra like a seminar for maths if I remember right. මම චුට්ටක් එක බලන්න. එහෙනම් බැරිනොත් අපි normal විදිහට කරමු. But if that is possible, I think that would be great. So for lesson 6, 8 and then 9 මොකක්ද? What's lesson number 9 ළමයි? Just to check. 9 තමයි resultant නේ. So 9 ඉවරයි. So let's quickly go over it. අපිට 1 2 3 4 ටික ඉවරයිනේ කොහොමත්. Then 6 we have to do, 7 done, 8 we have to do, 9 done, 10 we have to do, 11 done. Tennis chemical bonds. So 11 is turning effect. Turning effect is what we are doing still. 12 done. So next week we'll be done with 11 and then we can do either 6, 8 or we can go to 10. Okay. So 6, 8, 10, 13, 14 ඔක්කොටම PDF තියෙනවා. Right. 6, 8 එක තමයි there have been some issues in the notes so I had to redo them. තාම මං විශ්ලිවට යවුවේ නැහැ මොකද 8th lesson එකේ there are some things to do but කොහොමත් අපිට අද use කරන්න වෙලාවක් හම්බ වෙන්නේ නැහැ නේ කොහොමත් so ඒකින්ද it's okay. But I will share those. But 10th lesson and 13, 14 ඒ ටික නම් ready print PDF තියෙනවා. ඒ ටික මම කොහොම මිස් දේවියත් එක්ක share කරන්නම්. Also ඉස්සරහට LMS එකට මේ notes දාන්නම් so it's easier for you to download whatever is required. Okay. For the newcomers, if you're continuing the class, let Miss Divya know. ඔයගලන්ට links එම ඔක්කොම එවයා. And others and everybody, I hope everything that we did today is clear. If you all have any questions, you can ask. And I think that's about it. Do you all have any questions? Or is everything clear? Okay. Then let's wrap up, Lamai. I hope you have a great week. And good night. Good night. ඔයගලන් leave වෙන්න මම චුට්ටක් මේ Zoom එකේ ඉන්නවා so all of you can leave. Huh? No problem. Just I have to check something. Okay, good night. Bye.
Thank you. Good night, teacher.
Good night, teacher. Thank you, teacher.
Good night, teacher.
Good
Thank
night.
you.